Hello everybody, this is Professor West. Welcome back to C# programming. In the last segment we dealt with functions, which functions, which as we learned is very similar to the main function. It's just a chunk of programming or a chunk of code that's set aside separately from the main function that you can call to run at any point that you like. In this last segment we're going to talk about arrays. Arrays are sort of like complicated variables. In fact, the best explanation I've ever heard of an array is that it's a variable that can have more than one value. So I pulled this up so you can see what I'm talking about here. Until now we have said like x equals 5 or name equals Bob Smith. Why not? So each variable had one value assigned to it. X would always have the value of 5 until it was changed. And it would have no other values until the time came where we redefined it and gave it a new value. An array, on the other hand, is sort of like a group of variables that have the same name. So let's call this one numbers. And notice that right now I've got 5 spots here, and they're numbered 0 through 4. This is called a subscript, and you use number and subscript to identify this cell. It's kind of like in Excel, if you've ever used Excel, how we have A, B, C, and 1, 2, 3. So imagine, let's take it away from being numbers for just a second. Imagine this was a classroom, and this was one row of students, and you didn't know the students' names. And you point to the second student and you say, "Hey you, what's your name?" And they say, "My name's Bob." And so now you know. Let's do it with students. Now you know that students, and the second one is Bob. It's the exact same thing. And then, now let's say this one's Sherry, and let's say this one's Amy. So I could come up and say, oh, okay, student at subscript 3, and the computer would know, oh, okay, that's Amy. Just like when I said x equals 5 or name equals Bob. Now I have my name of my variable, or actually an array, and I list which spot it's in, and it knows the value. So this is very, very useful, because now instead of, if I wanted to do a search, like let's say I had 10, let me scroll back up. Let's say I had name equals Sarah Smith, name equals Jane Doe, and name equals Larry David. If I were doing variables, I would have to do something like this: 1, 2, 3, 4. Now each one of these would be separate. So if I wanted to see if one of them's name, if I said output a name you want to search for, and I accepted it as a variable called temp name or something like that, I would have to say, is temp name the same as name 1? And if it's not, then I would have to have a whole nother if statement that said if temp name is the same as name 2, if temp name is the same as name 3, if temp name is the same as name 4. So if I had 10,000 names that I was keeping track of, that would be 10,000 separate lines of code just to check to see if the name exists. And then of course you want something to happen when it does, so each one of those options would also have to have additional code to let me know what happens if it's there. So if there was 10,000 names, now I'd be looking at 20 or 30,000 lines of code, and that could get really, really complex. However, now, because I'm using an array, even if it has 10,000 names, I can still do all that in 5 or 6 lines of code. I do that by simply using a variable to tell it, okay, in students 0, is it the same? Okay, then add 1 to it. Now we'll go to 1. Is it the same? Well, let's add 1 to it until we either find it or come to the end. So this can be a very powerful tool that can save us a whole lot of time and effort in our programs. And I'm sorry to be so long in the explanation before I get to actual coding, but I wanted to explain what was going on before we do it. And now that we're going to do it, you'll be able to see it in action. So you'll understand a little more of what I'm talking about. So the proper way to define an array is to put the variable type and then, and then what we call a bracket. You put the open bracket, and just like before, it put the closed bracket for us automatically. And then we put the name of the array. I'm going to call this one numbers. Why not? So if this were a regular variable, I would have said, int x equals 5. Why not? But since it's an array, I have this box here because I have the open and closed bracket, which lets the computer know that it's an array. And now, instead of just saying equals and having a number, I have to be a little bit more complex. I have to tell it how many, equals new, int, and then I have another set of brackets. This time, I'm going to tell it how many places to have. So, I'm going to say 5 for now. What that's going to do, let me go back to my example here. It's going to create one called numbers. That's what I named it. I named it numbers, so it's going to create an array called numbers that would be integers, not names. And I told it to have 5 spots. And as we've learned before, it starts with a 0, so 0, 1, 2, 3, and 4. Now, what that means is I have basically on my hard drive something similar to this, where I have 5 spots reserved together so they can always be accessed as part of this array. Now, the next thing I'm going to do, I could leave it like this if I put a semicolon here, and I just wouldn't have any values assigned to the array yet. Or if I already know the values, I could go ahead and I could assign it. I do so by having my brace and then do the numbers. So let's say 5, 8, 2, 10, 3. Why not? And my semicolon at the end. Now, in my example from before, the computer would see this, it would create my array called numbers, and then it would say, oh, okay, this first one's going to be a 5. This next one's going to be an 8. This next one's going to be a 2. This next one's going to be a 10. And then this last one's going to be a 3. So when I tell it, hey, computer, what is numbers at spot 2? It's going to look over here and go, oh, okay, well, that's a 2. If I say what's numbers at spot 3, it's going to come down here and look and say, oh, okay, well, that's a 10. Just the same as if I said x equals 5. Numbers 3 now equals 10. So don't worry if that doesn't make a whole lot of sense yet, because a lot of times you just have to work your way through first, and then we can be done with it. Then we can start to understand it. So, the next thing I would like to do is output each of these to the screen. So let's have, remember a while ago I told you in an earlier segment when we were doing loops, I said there's one more kind called a for each loop. That's what we're going to be using now. For each, int numbers. Now what this does, a for each loop is specifically made to search an array, to start at the beginning and work its way to the end. So you'll only use a for each loop with an array, and I'm going to tell it I is my starting variable, or I is the variable that I'm going to use. And just like before when we did loops, remember we created an array? We created an integer and we often called it I. We usually set it to 0 at the time. Do you remember that? Now we don't have to, because a for each loop automatically knows that we're going to start at 0 and we're going to keep going until we get to the end. And then we put in and we put our array name here. So the last part that we need for this to run is going to be a console dot writeLine, and we just got to tell it what to output, which is going to be an I for now. When I run this, it's now going to create this variable called, or create this array called numbers. It's going to have 5 spots. It's going to assign these values to it, and then it will go through and it will write each of these numbers. So let's test it, make sure I didn't mess anything up. And there it goes, 5, 8, 2, 10, 3. That's all there is to it, guys. This is an array that has those values in it. Now, there's always more that you can do. So let's say I want to add more lines of code. So, of course, I need to add the braces. Because, remember, everything now within this brace, from this one to this one, will be part of this for each loop. So I can have all these lines of code exactly like I would any other time, just like we did with the main function. Everything in these braces are part of this main function. Everything in this set right here is part of this for each loop. So let's say I want to have an if statement. If I equals let's say 10. Then we're going to output it. Let's see if that'll work. We run it. Oh, it only did it on the one line. Yay, because that was the only line where the value was 10. And we can always change it up. I just wanted to show you that now this way. So had I changed my mind a little bit here, I could have done a search. I could have said, you know, output, please enter a number, input, you know, accepted as X or whatever. And then here I could have said if I equals X. And, well, heck, let's do it. Console.WriteLine. Please enter a number to search for. I didn't put a space in there, but that's okay. I don't really care. And then let's say I've already got the variable X, so let's say X equals convert to int32 console read line, and then I'm going to say if I equals X. So now I get to pick what number it's searching for. Let's run it and see. Please enter a number to search for. Okay, let's do 2. And I messed up apparently because well, that happens in the programming world. What did I do wrong here? I see what I did. Okay. Hopefully you've all spotted it by now, but if not, let me explain it to you. The very first time this went through this loop, it started with I being 0, which pointed to this first one, and it asked me to enter a number to search for. When I put in X, I put in 5 or whatever, no, 2, I think I picked. It came through and it said if I is 2, which it's not, because it was I equals 0, which pointed to the number 5, right line. Then it came back up and it asked me again to enter a number. I messed up and put these here. Let me crunch those out of there, when I should have put them before the loop, because I wanted it to ask one time to enter a number, I wanted it to accept that number one time, and then I wanted it to go through the entire array searching for that number. That happens sometimes. It's a very easy mistake to make. Let's see if it works better now. 2. Oh, it found my 2, and now I'm pressing exit to enter. That didn't really tell me much though, so let's give it a little something to tell us. We found zero at, let's see, actually let's see, we found x at, let's do index, and I'm going to have to create another variable in order for this to work. Quote, semicolon, and I'm going to call that variable, let's see, let's have a variable called int I count equals 0, and now I'm going to say at semicolon I count, and then I'm going to I count plus plus. Let's see if that works. If it does what I'm attempting to do, I don't think I did that right though. That's okay. It's always fun to try to figure out why it didn't work. And it appears that I put semicolons instead of commas. With the loops we were using earlier, we had to use semicolons in our for loops, and I guess I got used to doing that. Okay, please enter a number to search for. Let's do 2. We found 2 at index 2. Is that correct? Let's take a look. Spot 0, spot 1, spot 2 has a 2. So far it's looking good. Let's test it again. Please enter a number to search for. Let's do 10. We found 10 at index 3. That's right also. So let's see what happens if we did not find it. Enter a number to search for. Let's try 11. And we did not tell it anything to do if it didn't find it, so it just ends. But here's the kicker. And this is what makes arrays so popular and so powerful. Right now, I have it set up so that I have a 5-element array. If I simply change this, now I have 10,005 elements. Of course, obviously, this would have to go. I would have to have some kind of a program that would, like if it's in a file or something, if these numbers were in a file, I could read that file and assign each number into this array. And then this code that I have here that tells it to start at 0 and go through the end of the array would search all 10,005 of those indexes, and anytime it found the number it was looking for, it would tell you what line it was on. So this little bit of code, remember a while ago we were talking about how you had to have, if I use a bunch of variables, I would have to have 3 or 4 lines for each one. Now these I don't even count this as a line of code. So 1, 2, 3, 4 lines would search my 10,000 element array. That's part of why arrays are so incredibly powerful. So anyway, let's do a different array. Let's do one with a string so you can see how they work. Let me get rid of this. And let's have string brackets. And I'm just going to call it names for simplicity. And equals new string, and let's say I want 4 spots in the array. I want this array to have 4 places. So the indexes will be 0, 1, 2, and 3. So now let's have let's have a for each. Let's say string s. Just like integer I, we often use string s for variable names and little short snippets like this. In names. And what do I want to do? I want to say, let's have braces. And let's say console.writeLine. Please enter a name. And then I want actually, let's say names not int, or no, actually, I'm going to recreate my variable while go that I use called counter. And I'm going to say here, let's see, names counter equals console dot read line, because I want to read the entire line, and then I'm going to increment my counter. So iCounter is going to be 0. When it comes through the first time, it's going to ask you to enter a name. It's going to assign whatever I enter. It's going to accept the entire line, and it's going to store it to the array called names at the spot at the index of iCounter, which is 0. Then it's going to increment by 1. So the next one will store at spot 1, then at spot 2, then at spot 3. Now let's tell it to output, just so I can, for each, let's do it again, string s in names console dot write line s. So once it finishes, it'll ask me for a name, store it into the variable or into the array, ask me for a name, store it, ask store. When it's finished, it'll come down to this for each, and it'll output all the names. At least that's what we're hoping it will do. So let's give it a try. Please enter a name. Let's say Bob Smith. Please enter a name. Let's say Karen Monopoly. Please enter a name. Susie. Okay, let's say Susan, because I don't know how to spell Susie. Susie Speaker, and Larry Lightbulb. Yes, I am naming stuff that's sitting on my desk, other than Monopoly. I don't know where that came from. Oh, there's a Monopoly piece. Kroger's doing Monopoly right now. So, now that I'm finished, I hit the button, and all 4 names appeared. So what happened was, as I said, it stored each name, and then when it was finished, it outputted each name. If I want, I could come here and have console.writeLine. Give myself a little bit of room here. Let's try that again. Okay, Bill Davis, Jeremy Sunshine, spelled weird, Larry, I don't know, Cloudy, and let's have another Bill. Why not? Bill Smith. So you can see, as we said, each one of these was stored into the array, and now they come up. There's another interesting thing that we can do with arrays, and it's called sorting the array. Now, in a lot of other languages, you have to go in and physically sort your array. But in C#, you have a command to do it for you. It's array.sort. And then you put the name of the array, and that should put everything in some sort of order. Let's give it a try. Bill Davis, Susan Johnson, Larry Smith and Dana Pointer. And what kind of order did it put it in? Well, as you can see, Dana was the last one. Now she's the second one. It put it in order simply by the very first name. If I had been doing last name, comma, first name, these would all be now in order alphabetically by last name. But as they are, they're alphabetically by first name. So you can do the exact same thing with the numbers arrays that we were dealing with a little while ago. If we didn't already delete them, let's just redo them real quick. Won't take but a minute. So int bracket numbers equals new int. Let's do 10. Why not? And let's go ahead and give them some values. 65, comma, 47, comma, 21, comma, 49, comma. Let's do another 49, comma, 12, comma, 98. Let's see, how many is that? 1, 2, 3, 4, 5, 6, 7. 3, comma, 76, comma, 24. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Good deal. So, as I said, simply use the array dot sort and tell it which array you wish it to work on, and it will sort your array for you. And then a simple for each int in numbers console dot writeline I. So here's the order my numbers are currently in, and then when it runs the program, that's the number after they've been sorted. 3, 12, 21, 24, 47, 49, 49, 65, 76, and 98. So this is how they are now stored in my array because I've sorted them. This means that 3 is now at the index of 0, 12 is at the index of 1, 21 is at the index of 2, and so forth, all the way to index 9. Whereas before I sorted them, 65 was at the index of 0. So, as you can see, that's a whole lot of stuff you can do with these arrays. Like I said a minute ago, without having the ability to do it manually like this, you actually have to go in and write the code that tells it to go through each one and move the smallest one to the left and the biggest one to the right. And I'm going to be doing Java pretty soon. So if you're interested, you might want to check that out, and you can see how to do a sort like that. In the meantime, I apologize for this one running a little bit long. I always try to keep them in under 20 minutes, but this one kind of got away from me here. But anyway, I hope you enjoyed arrays. Just so you know, this is called a single dimensional array because, back to my list, there was one column. But just like any table, you can have multiple columns. So if I had something like this, this would be a two-dimensional array. You can have 3, 4, or you can have a lot more than 2, but they get more complicated, and I decided to hold off. I just wanted to point out the fact that you could use them if you chose to do so. And anyway, that concludes these tutorials. I hope you enjoyed them, and I'm finished.